Time to start, actually. First of all, I'm really excited to stay here and giving that presentation for such amazing audience like you. And first of all, I'd like to say thank you. Thank you for coming, and thank you for showing you're willing to learn how to refactor your application to Reactive 1 with Spring 5 and Reactor. Before we start our talk, I would ask you to visit that link, and I would encourage you to take your phone, open your browser, input the following link on just scanning this QR code. By doing so, you will see the chat application, call it Gitter. And I will ask you to sign in to this chat room, especially to this chat room, Java Day Istanbul. You may have done that with Twitter or your GitHub account, and I'll encourage you to write hello there. It will make our presentation very cool and very interactive. And at least it will help me with presenting this talk. All right, this link will be popped up a few times during the presentation, so I'll start my talk. Who am I? My name is Oleh. I'm from Ukraine, from Kyiv, and I'm a Java software engineer, mostly focused on distributed system development with the usage of reactive technique, reactive programming, and reactive systems. I'd like to talk. I really love to talk a lot, and especially about Java and Reactive. And I do as much as possible to be a great speaker. And along with that, I do my best to help Spring and improve, especially Reactor, by sending some commits to that project, and especially by answering all possible questions related to this library. Along with that, I do my best to improve my local community, my Ukrainian community, by creating some interesting talk conferences related to Java. So if you would like to talk with me about Reactor or about giving a speech in Ukraine, you're welcome to follow me at Twitter or to add me to friends on Facebook, and I'll be happy to talk with you, with everyone. Along with that, I wrote the book called Reactive Programming in Spring 5. And that book covers almost everything that will be shown and demoed during our talk. And yeah, if you would like to talk about this part, we may do that backstage, but yeah, it's something that I already done. And over to the agenda. We will start with non-reactive Spring application. First of all, non-reactive because this is a great source of refactoring to Reactive 1, right? And the main mission and the main goal of our today talk will be achieving something like that. By the way, raise the hand if you know what is diagram or schema means. For those who don't know what this diagram means, is Reactive Manifesto. And this diagram describes the system, especially reactive system. And we will try to achieve this reactive system by building something like that, by building reactive natural flow of events. That's what we will achieve at the end. But first of all, non-reactive chat application. That will be the source of our talk, the main topic, the main application. This chat application has really plain and not complicated functionality. It can communicate with Jitter. Raise your hand if you know what is Jitter. For those who don't know what is Jitter, Jitter is chat, like hip chat, like Slack. Focus it on GitHub, especially on creating chat around your open source project and wiring some communication between folks and you. That's the main idea. And we will take some messages from chat room and display on our own UI. The second point will be calculation sums of statistics, especially calculating the most and finding the most active user in that chat room and finding the most mentioned user in that chat room. That's what we will do. And instead of talking about functionality, I just show you that functionality. Again, here is the room. I'll encourage you to visit that and join the chat. And this is the right time to start writing some messages here. So here's our application. Yeah, great, thank you. There is some messages here. I will send some messages as well. Here is the application, my mobile application. And yeah, hello. And here should be, yeah, it's me, great. It works, it's real application, it displays some messages. And in turn, here is the part related to statistic. You see, the most active user right now is me. If I mention someone in this chat, you will see that this statistic will change. For example, let me do so. Come on. Yeah. And now the most mentioned user is Oleh, or I don't know, sorry for that. And yeah, this is our application. Let's go back to our slides. And what is going on behind this scene? That is the most interesting question, I believe. First of all, what toolkit is used there? Here we use Spring Framework. Other Spring Framework developers? Great, a lot of hands. Along with Spring Framework, we use Spring Web MVC. Great. And we use Spring Data MongoDB to communicate with our MongoDB. Great. And yeah, to run our application, we use Spring Boot. That's our plain, not complicated toolkit. Everyday toolkit, I believe, in every Spring Framework project. In turn, the second interesting thing that should be discussed there is architecture. And architecture is more simpler than the toolkit. Here we have three main components in our application. The first one is browser. It's your phone, it's my computer, it's browser, or client. The second part is source of the messages, or getter. And the central part is our application, our server, written using Spring Framework. And here we have really plain architecture. We have controller layer, we have service layer or business logic, and we have communication with database or persistent layer. So it's plain three-tier architecture. Let's ensure that, first of all. Let's ensure that this is like that. Here we have like our Spring application. Really plain Spring application. Here we have controller layer. Here we have services or business logic where we have some services and implementation of these services. And here we have communication with Spring Data over repositories, right? That's our plain architecture, and this is our source of work. And the final things related to what is going on behind the scene is existing flow. This is the most interesting part, how our communication between client and server is wired. First of all, we're asking for view. That's the first part. Then we're asking for messages from getter, and we have to wait for them, for those messages, because it's blocking. It's plain Spring Framework, right? The second part, we should to store all the messages, and we have to wait again. And then we have to recalculate our statistic because the data has been changed. And we have to wait again. That's what we do all the time. And finally, when all the data is available for aggregating, we will respond with some UI. Along with that, we have small JavaScript, which is asking a few seconds for the same information. Ask and ask and ask and ask and ask, again and again and again and again. So it's a similar flow. In general, we have really everyday familiar Spring Boot application. Along with that, we have plain three-tier architecture, which is, I believe, most common architecture in the most project. Along with that, we have common interaction flow. At least I did the similar application, like with asking, asking, asking. And finally, it just works. It brings some value for the business, and that's it. That's the main things related to this application. It just works. So what's wrong with that? How do you think? I see some problems, some main problems related to wasting of the resource, and especially wasting of the resource over pooling model or asking. Instead of reacting to events, we're asking for them. We're asking for all the time, like that.
Mom!
Like, Mom, is there a new message? Other new message, Mom.
Mama! Mama! What? Hi.
And all the time we're just asking instead of reacting to new messages. And that's the first wasting. And the second wasting is blocking. Instead of sending a synchronous event and just doing another stuff and then reacting to the response, we're just sending the event and blocking and wasting our CPU on context switching. That's the second problem. And the final problem is the absence of responsive. If we try to disable some of the important components, or if we try to stop our MongoDB like that and reload our application, we will see the error message after 30 seconds, which is the default delay which is default timeout for MongoDB. So that's the three problems of that application. And we may solve it with reactivity, especially with reacting. Instead of asking, we may react to events. Instead of blocking, we may send a synchronous call and reacting to them. And instead of being non-responsive, we should create responsive reactive system. So the main question, how to be reactive? And the answer is really simple. With Spring 5, of course, especially with new web flags, and which is a new web flags is absolutely similar to WebMVC. First of all, to recap what is web flags and understand what is web flags, we try to recap what is WebMVC. And WebMVC is something like that. We have a really plain annotation and programming, annotation-based programming model, which is powered by Spring WebMVC model, which is built on top of Servlet API and Servlet container. In turn, reactive stack absolutely similar. We have the same programming model, the same controllers request mapping, which is powered by new web flags model and new architecture, which is absolutely based on reactive stream and reactive programming. And that new reactive stuff may run on top of Servlet API, as well as new powerful asynchronous servers like Netty or Undertow. The core component of new web flags, which allows us writing some transparent, clean, understandable code, is Project Reactor. And Project Reactor looks like that. And what you have to know about Reactor is two main things, two main reactive types. Which the first one is mono, which allows us processing 0 or 1 element asynchronously reactively. And the second reactive type is flux. Flux allows us processing 0 or stream, infinitive stream of elements. Along with that, you will see in the code something called publisher. And I just mentioned here that publisher is related to reactivity, especially to reactive. So if you see that, just don't worry and remember that this is related to reactivity as well. Finally, if you'll try to assess what is the difference between writing the code in Spring WebMVC and Spring Web Flux, here is a simple, familiar REST controller. The main difference is that controller is reactive type, and that's it. OK, to summarize, to be reactive, first of all, we have to use Spring Web Flux. The second thing, we have to write our code using Reactor. However, that's not all the things. Along with using fancy framework, we have to change our mindset. We have to choose our design or refactor design of our current application. So first of all, we have one main problem, and that problem is pull-in model. And we have to replace pull-in model with push model. All the data should be pushed from Gitter to our final client. And to achieve push model, we have almost everything that we need. First of all, we have Gitter streaming API that allows us wiring continuous communication or continuous connection with Gitter and react to all new messages in the room. The second point, we have reactive Mongo driver, which allows us asynchronously communicate with database and react to changes in the database. Along with that, we have WebSocket, which is verified by the time solution for wiring communication between browser and server. And finally, we have reactive server, like Netty. So we have all required stuff to run new reactive system using Spring and Reactor. So let's do it. Let's try to refactor the code. And first of all, we have to start with refactoring of our updating our dependencies, of changing our old Spring framework to new one. First of all, here is our Spring Web Flux and Reactor. And along with that, we have fully supported with reactivity all required modules, like Spring Boot supports reactivity, Spring Security supports reactivity, Spring Data supports reactivity, and Spring Cloud supports reactivity. So the whole ecosystem works with reactive types, with Reactor, and that's amazing. That's the essential part. Unfortunately, we have to migrate from Spring Boot 1 to Spring Boot 2, because Spring Boot 1 doesn't support reactivity. So the only thing, the only requirement is migrating to Spring Boot 2. So let's do it. Let's back to our application. During the whole code session, I will apply some changes by applying the commits. So that will be the way of our coding. And the first step is applying new updates, new dependencies. And here is the changes. Here we have Spring Boot 1, Spring 1.5.12, and here is Spring Boot 2. Do you see that? That's the first changes. And then all we have to do is replace Spring Web with Spring Web Flux and replace Spring Data Mongo with Spring Data Mongo Reactive. That's the second two changes that you have to do to move to Reactive framework, to new Spring 5 and new Spring Boot 2. And if we try to compile our application, we'll try, yeah. You will see just a few compiling errors in the code. Come on, where is the errors? Okay, let's update our dependencies first. Yeah, here we are. Just small error, and we may just fix it right now, because that's API changes, and by providing out save all instead of save, we will fix all the problem, I believe. Okay, here is another small problem, so just don't worry about that. All right. Back to our presentation. To summarize, first of all, we have to change just a few lines of code to achieve new reactive Spring framework in our code base, in our application, to move to new reactive Spring. And the second thing, great thing, that we have to change just a few errors in our code, and our application will be working, will work. That's the first step. The second step is refactoring contract, or refactoring communication between components, communication with external services, and communication with the client. And to achieve that part, we have, first of all, change our contracts or interfaces. And we have to change our imperative communication to reactive. We have to change object to mono of object. And we have to change our collection, like iterable, to flux, because Flux is a stream of objects or stream of elements. Along with that, there is some exclusion, there is some different, there is some exclusion from that rule. In case if you change your pooling model to push model, you have to change your imperative object to stream of object because it's changes of the whole stream. It's like moving to the stream instead of just pulling. That's the one exclusion. Along with that, we all know that communication with database are done over interfaces as well, especially over CRUD repository, for example. And the amazing thing here is that we have reactive CRUD repository, which looks like that. And the most important here, and the most significant, that everything right now supports reactive communication using Reactor and Flux and Mono and publishers. So Spring supports us everywhere where we need reactive communication. And right now I'd like to apply the changes, and I'll show that we have such amazing thing in Spring Framework. First of all, I'd like to move our database communication. I would like to change communication over repositories. And here I apply our changes. For example, here we have our message repository, which extends Mongo repository. And the only changes here is reactive Mongo repository instead of usual one. So that's the thing that we have to do here. Along with that, if we have some complicated, for example, we have some custom queries to Mongo, for example, we don't have to change a lot as well. Here we have just change in Mongo operation to reactive Mongo operation, which supports reactivity from scratch again. And that's all the things you have to do here. The second step is moving your interfaces, of course, or changing your contract. And here we have, just a moment, yeah. Here we have some changes. For example, here we have iterable, which has replaced it by Flux. And here we have the similar. Here we have lists, which was replaced by Flux again. And here is example of exclusion from that rule. Here we have just one object, which was replaced by the stream of the object, because we totally changed our communication model between our statistics server. We transformed it from pooling to push to streaming. That's why we have such changes, such replacement of one object to stream of the object. All right. OK, what to summarize from that part? First of all, we have to use Mono for request-response communication. And the second point, we have to use Flux for request streaming. The final part of refactoring, of course, we have changed our dependencies, we have changed our contracts, and right now we have to change the whole code base. We have to rewrite our application to be able to be fully reactive. First of all, I'd like to notice here is that we have to change our mindset first. And we have to think about everything as a stream. All events is a stream of events. And we have to use only non-blocking communication here. First of all, I'd like to start with jitter, because jitter is the source of the messages. This is the very beginning of our stream, right? And any communication with external services previously was done with the support of REST template. Do you use REST template in your code? Yeah, great, super. And REST template is replaced in new Spring, especially new Spring Web Flux, by a new web client, which looks like that. The most essential here is, again, reactive types. Do you see it? And now I'd like to apply the changes again as well. So here's our code base. And yeah, here we are. here we have some list of changes, some significant list of changes, because it's moving from one communication to another. And here we have our REST template. And here we have communication over REST template. And that communication has been replaced by new web client, which looks like that, which is totally based on new reactive types. That's fine if for some moments that code is totally unclear, but we will discuss that part later. Along with that, we have some changes in the communication or in the business logic, which is related to changing the pulling model to push model. Yeah, I understand that it's unclear for now, and I'd like to back to presentation and show that code again. Here we have our web client. And the most significant part, the most exciting part here is that operator. By applying such operator, we'll be able to achieve resilience. We'll be able to isolate our system, our code base, our application from external errors. And we will be able to, in one line, retry to reconnect or resend new requests to external services. And in that way, achieve resilience of our system. Along with that, this is the second part. And the most essential here is that operator, which allows us being responsive all the time by applying caching to our stream, by caching some portion of the messages. And by running that code, we will achieve something like that. And by running that part, we will be able to connect to external services, receive some messages, and that messages will be stored in the cache, in the reply operator. Then this part will be disconnected because this is just the last messages. And eventually we get some new messages, which will replace, and new messages will replace the oldest one in the cache, and we will have only like the most newer portion of the messages. Along with that, when user connect to our system, he always receives some portion of the messages, a portion of cached messages. And suppose that we have some disconnection or some problem with our network. And regardless, if new user connect to our system, he will receive messages, and our system will be responsive, regardless disruption of the network. Along with that, we have retry in web client code. And that retry will try to reconnect, and eventually that reconnection will be successful, and we will be able to reconnect to external services again and receive new messages again. Okay, what to summarize from that part again? First of all, Flux retry enable resilience in our code, which is important, which is a part of Reactive Manifesto, which is a part of Reactive System. The second thing is Flux reply, which allows us being responsive, caching some portion of messages, and regardless some problem, always respond to the user. The second thing is message service, is the middleware of our processing flow. And here is the similar advice as previously. So let's just do it. Let's just apply new reactive stuff to message service. And here we have some changes, again, related to moving from pull model to push model. Here we have some stream of messages. Here's some subscription to Jitter client. And here's some part related to restreaming the messages from Jitter to our UI. Again, what is going on here? First of all, again, we have retry operator, which isolate our code base, our server, from external database, from MongoDB. Again, we enable by doing that resilience. If we run that code, we will get something like that, the similar execution flow. And when the messages will be received, it will be transformed, and it will be stored in the database. That's the happy path. But the most interesting is unhappy pass. For example, when database become unavailable. In that case, retry operator will store all the messages and will try to store it again, and again until success. And when the database become available, we will store all the messages here. Okay, what to summarize, what to take away from that part again? First of all, retry. And the second part is reactive database, which allows us wiring end-to-end reactive communication. All right. The final part is statistics service. This is the most complicated part because we have a lot of code and a lot of business logic here. And let's take a look on it. Okay, let's apply new changes, and let's try to achieve some reactivity in calculation of statistic as well. Here we have a lot of changes. Not here, but here. And that's like a small problem, because we have to rewrite almost everything from scratch. But that's fine. That's all we have to do. And let's analyze what is going on here as well. Here we have that part of code. And the most essential, the most significant part here is that one. That is the ability to be resilient in the case when we have a lot of messages. To not overwhelm our application, we enable back pressure strategy. And in that case, all the messages will be skipped, and only the last one will be stored in the cache. Along with that, we have cache operator, which improve overall user experience and which enables responsiveness and better user experience in our application by caching the latest statistic in that operator. By running that code, we will try to connect to all events from Spring application context. We will be listening to that. And since this part is just asynchronous communication, callback-based communication, we will try to adopt that part using Reactor API. Here we built another part of the stream, and here we try to carry the messages. Caching the messages calls the first request, and we will do some first calculation of the statistic, and we will store that. Eventually, we will receive some messages here, and we will run some calculation of the statistic. And in case if we have some new messages, we will just skip it, and when the calculation of the statistic will be available, only the last one will run new recalculation of the statistic because we're just listening for the fact that something has changed in the database. So to summarize, to highlight the most important parts, first of all, there is built-in back pressure support in Reactor, which is amazing. We don't have to care a lot about that. We just to have apply one operator to enable back pressure support. Along with that, we have Flux cache, which allows us caching the last one element in our stream. And finally, we have Flux create, which allows us adopt everything. All we have to do is just apply one operator to adopt callback-based asynchronous communication to reactive one. And finally, is wiring new way of communication between our web client or web browser with our server. And all we have to do here is moving from Spring Web MVC to Spring Web Flux, and especially to new reactive WebSockets. What's new in new reactive WebSockets? Again, communication over fluxes, and monos. End-to-end communication over reactive types. The final changes in our code. Here we have a lot of changes because we're moving from REST communication, REST controllers, to new WebSockets communications. That's why we have a lot of changes in our code base. But the most significant here, again, that to merge two streams, statistics stream and message stream, we have one operator called merge. which allows us merging two streams in our network or in our WebSocket. Of course, we have to change the tests, but this is not a topic of our discussion for today. I just apply the changes as well. And let's analyze what is going on behind the scene. First of all, we will get similar execution tree. When we get the first messages from the getter, it will be merged to the network. If we get the statistic, it will be immediately merged to the network as well. That's how it works. And finally, to summarize, we have to apply just one operator, merge, to merge all available streams in our system to WebSocket, for example. All right. And now let's check our goal, our last point, our architecture. What is going on right now in our application? Right now, we have a natural flow of events from getter to our final client, to our final browser. That's what's going on right now. And let's check it. Again, I encourage everyone to join the chat. And yeah, first of all, I'll remind you that our database is unavailable. The second point, I have to rebuild our application. We have to check that everything is fine. Yeah, everything is fine, I hope. Now we will try to restart our application. Come on. Yeah. Here we are. If we will try to reload our application, we will see it works. Even if database is unavailable right now, it works. It just works. Moreover, I'll try to disconnect from the network. And if I disconnect from the network, I will lose the connection with getter. So I'll do that. And regardless of the disruption or disconnection from the network, my application is still working. Yeah. I just reloading the page, and that's it. OK, let's try to enable our system right now. And let's try to see what will happen. First of all, I'll try to run the database. And yeah, statistics become available. Do you see that? Here we have the actual statistic from our database. In turn, if we try to enable or connect to our Wi-Fi again, come on. Yeah. And we will try to send some new messages. I am waiting for loading the application. Come on. Demo effect, as usual. OK, let's try to do it again. Connect and disconnect. Yeah, here we are. Do you see that? After the disconnection, our application starts receiving the messages, which is amazing. We just keep our application as it is and just restarted the connection with the network, and messages, and the server automatically reconnected to the external jitter service without any additional effort from our side, such as restarting the server, just by applying one retry operator. That's amazing. All right, let's back to our presentation, and let's check according to our main goal, main mission. And our main mission was achieving reactive system. And first of all, by applying new reactor and new spring, reactive spring, we were able to achieve resilience. You saw that after disconnection from the network, from the database, our application still was still working. In turn, the whole communication is message-driven on some level in our application. So we have a synchronous message passing in over our streams or over our fluxes in monos. And finally, we have responsive application, which respond to the user regardless external services and external disruption from the network, et cetera, et cetera. However, there is some unclear point related to elasticity, because elasticity is something, the ability to accept more user when it's needed, and decrease the ability to accept new user when the throughput decrease it or the interest to our service decrease it. And we can't just add in new cores or new processors, at least to my laptop right now. That's why elasticity is one missed point. However, one machine that I'd like to add related to achieving the elasticity is new model. It's not new, but one important model in Spring ecosystem called Spring Cloud Stream. And by applying new Spring Cloud Streams model, we will be able to achieve elasticity in our system. And I'll encourage you to do so at home. There is the last commit, which apply to our application Spring Cloud Streams model and allows create fully reactive system with the support of Spring ecosystem. Finally, what takeaway from this presentation? First of all, let's remind that we have to move from imperative communication to reactive communication over the changes of our imperative type or synchronous type to reactive, asynchronous type. In turn, we have to move our communication or interaction with database from synchronous to asynchronous or reactive, from CRUD repository to reactive CRUD repository. And finally, we have to move from REST template to web client, which allows us wiring some asynchronous reactive communication between external services. Along with that, we have to move, and I suggest to move from Spring Web MVC to Spring Web Flux, and of course, moving from Tomcat to highly powerful Netty server, which is designed for asynchronous, non-blocking communication between services, et cetera, et cetera. Finally, I'd like to share some disadvantages of that technique, because it's something important for us. We all developers, and we have to understand with which things we have to do, we have to deal, first of all. The main big disadvantages is understanding. There is some learning curve of learning Reactor and new Spring Web Flux, and we have to do some reading, some learning, some playing with the code to understand how it works. And we have a lot of operators in there, so we have to learn all of them. In turn, sometimes we have to rewrite the code from scratch, like it was with REST template to web client example. In turn, unfortunately, we don't have reactive JDBC, and the most of the project still based on communication with such databases like Oracle or MySQL, which is based on JDBC driver. And JDBC driver is a blocking one. But I'll encourage you to join backstage discussion, and I will show a few examples how we may refactor our JDBC to make it kind of non-blocking, how to hack that part. Finally, the challenging part is debugging, and you have to learn how to debug your application. On the other hand, we have a ton of advantages here, and the first advantages here is reactive system, which we will be able to achieve with the new Spring framework. In turn, we will get higher throughput of our application by using reactive asynchronous communication and non-blocking communication. In turn, we will use less memory than with blocking communication, because we will use fixed amount of threads instead of providing thread per request. And finally, that's the same Spring framework, the same annotation, and all the same related stuff. I believe if you're curious about reactive programming, I'd like to suggest you a few links related to learning and understanding the reactivity. The first one is why reactive. This small paper describes the sense of reactivity. After understanding the sense of reactivity, I'll suggest you to play with WebFlux. This is a workshop from one of the guys from Spring Framework team. But WebFlux is not enough. The essential part of learning reactivity is Reactor. This is the core part. And you have to play and learn new Reactor and new reactive programming. Finally, if you would like to understand some pitfalls or hidden approaches and hidden things in the reactivity, I'll suggest you to read Netflix blog, especially their story of migration to reactivity. Finally, the code is available here. It's not production-ready code, but you may play with it. So I'll encourage you to do so. And finally, thank you. Thank you for your time. Thank you for willing to learn new reactive application. And the presentation is available by that link. Thank you again, and all questions are welcome.